Hello, professional developers. My name is Alexey Kozin. I have 15 years of professional software development experience. This is a lot, this is quite a lot. And on this channel, we are practicing together and growing together as software developers. We are doing not like junior developer stuff. Yeah, we are not doing lead code problems to pass interview. No. We are practicing real life software development problems and train real life software development skills. So let me onboard you on what we are doing here. We take big open source software project like NodeJs and take an issue inside this project and try to solve this issue. The good issue to practice on has two components. The first component is this is a big software project written by the greatest developers in the world. This is like really good guys. We can read their code, the top developers' code, and learn from it. The second component is you should pick an issue that is quite hard. For example, this one was very hard for me. Like I was not sure that I can actually complete it. So let me onboard you on this issue. It's quite straightforward. We have JavaScript function and we have like C library, and we want to pass a lambda from JavaScript to C library. It has multiple layers, a pretty fun feature to work in. So I will give myself, as usual, I will give myself 45 minutes and let's begin. So on previous episodes we almost did this feature, so the only thing need to do is like call the callback correctly and return some values. So pretty much it. So currently, hold on a second, let me put my bookmark on the thing we are doing. So on previous episodes we almost did the feature, we passed some lambdas. Now the only thing we need to do is to pass arguments. So currently on Conflict don't get arguments from C++ layer, and I believe the return value doesn't pass further. Oh no, we have return value. Oh, okay. So the only thing need to be done is to pass some arguments to JavaScript function. On a C++ layer, on a V8 layer, I believe arguments of C++ of JavaScript function looks like just an array of something. We pass array and then V8 deconstructs it to like different stuff like this. It's just one array. So I'm not sure. I have a call. So we have our callback and we call it, but this signature, I'm not sure about this signature. Guys, I don't know what this signature does. So let's find some examples. So the good strategy in a new code base is always find some examples. In a perfect world, I could like select the whole block and try to find fuzzy find with some neural network across all the code base similar code snippets. Perhaps the next project will be like this finder, but today like let's use the standard finder. Standard finder just finds all references to this call function, so we can like scroll around it and see how people use this function. So I believe there is like 3 arguments. The first one is context. Context, it's like just a global JavaScript state, nothing interesting. The second argument, I believe, is this, context, ref. I am not sure what ref is. The second argument is not, it's not clear what the second argument is, but sometimes people would like just pass like undefined. Sometimes they pass some pointer. I believe the second argument is just this. And the third and the first arguments are our function parameters. So how do we send parameters in C++? How do we do it? Do you know, guys, how to create array in C++? So, for example, we're creating here an V8 array. Do we need V8 array, or can we use the just array? Because data returns pointer to something. It's not like we need a real V8 array here. I think we can just pass a regular array, but let's search for examples. Args. What is args? Args lengths. My bad heart grows because it's hard to find something useful. I'm getting frustrated, but nevertheless, the best thing we can do is just read some examples. For example, this one. We just pass one argument. And look at this, guys, we don't need array, we just pass one argument and give a pointer to it. So we need just construct some number and pass it. And that's basically it. Try catch scope wraps how scopes works in V8. So you create a like variable on stack, and if we leave the scope, it will be auto collapsed and will release the try catch scope. It's interesting how it's done. So for example, we can do like this and try catch scope will be applied here. But this is like JavaScript try catch, not the C++ try catch. But I'm interested in like just creating a number and pathing it. So I believe I can grab just this code part, and let's put bookmark here. Let's put bookmark here so we never forget. And jump to different bookmark. Let's put bookmark here because we are working on this code parts. And what we need to do is just create a local variable. By the way, to which scope this variable will be attached? So in JavaScript v8, we need to attach local references to some scopes, and this is lambda. And lambda kinda out of scope. I believe they assume this JavaScript is single-threaded. So whenever was called by this apply same function, scope will be valid here. So scopes made via global state, and global state in the isolate. So yeah, they will take scope from isolate. So isolate is the JavaScript virtual machine. So here it's just number. We just pass here like our e-conflict, and this is like from C library. So once again, we have our C library. It has a callback. This callback accepts numbers, and we need to pass this number to the C++ layer or to JavaScript layer, and so we create a v8 number and just pass it. Let's call it like eConflict GS. By the way, is this eConflict? So how do they call it in C? Interesting. So let's jump to definition. So in C definition in SQLite they call it just eConflict, whatever. Let's call it the same. Jump to our breakpoint or just bookmark. Pretty interesting. So the only thing we need to do now, we need to just pass our pointer. So we need to get our pointer like this. I know why it works. I know why we don't need an array. So in C++, array is just a pointer to something, and then you have your elements stacked together. So because we have like one element and we say one element, so it's the same as an array of one element. So yeah, we can take an address of this value and just like treat it as an array that will work. So array is like pretty interesting in C++ and C and everything else low level. So we pass this. Now we should get this value in our JavaScript. So let's format our code. Let's auto format it and try to get this value in our JavaScript. So let's jump here. Let's put breakpoint here. So we call it eConflict, and this is like conflict type. Basically, eConflict is a conflict type. So let's run this test and try to get some breakpoints. How to run the test? We have a command dub new, and we should have why is this one? Yeah. So we have dub new. We need just call our JavaScript configuration. So we hit our breakpoint, and what the value is undefined. Hooray! it's not good. It should not be undefined. Why it is undefined? Why is it undefined? Let's jump to our example. So basically here we I know, guys. I'm getting the same issue each time. This is ridiculous. So this is C++, and to C++ code changes make effect, you need to recompile this. So I forget to recompile every time. This is like ridiculous. This is not a convenient feature of C++ because recompilation takes some time. So any change I do this layer, I need to recompile. And for JavaScript, it's not like this. I can like type here, and the changes will be instant. So I believe everything is cached down, and we will just try to run it. This will take like a couple of seconds. What else we can do? We can check other tests. So basically, we need to mutate all the tests from just constant to the lambda. Yeah, it will not take much time. Let's do it right now. Let's copy this and jump here, and we need to do like this, and bam, it's done. Conflict type, we can go wrong, ignore conflict type here, so we'll just return it. So yeah, recompilation is finished. So let's try run once again, and I believe this time we will get our value. So yeah, we got our value 3. And what is 3? Do you know what is 3? So this is like conflict type. And where can we find all the C++ conflict types? SQLite has some documentation about what conflict can be. Data missing conflict constant. In this file constant. Where can find the definitions? Data missing. I need to find some definitions in C library so I could export them inside our JavaScript layer. But I think I need online documentation of the C library. Hold on. So let's search on conflict, e-conflict. Yeah, we need like this, but inside our C library. This is like, here we go. SQLite constant or SQLite change send constant. Maybe I need just this one, guys. Let's search it. I don't have this. SQLite constant, maybe I have. I don't have this. I will search it forever, guys. Let's check the solution so we'll not spend our time searching it. Our solution is, I have closed it. So this is our solution, let's check it. So we not spend lots of time searching the SQLite constant. So, where is it? Where is it? How it's named? Once again, constant. Constant. Yeah, like this. Where is it? Where is our constant? Define constant. Data, no. Change set data. Yeah, this one. So this is how they name it. But why can't find it in SQLite layer here? For example, I can't find here. Here we go. Here we go. Here are our change set types. Okay. We will need to pass this constant inside JavaScript, so we can just like take it here, go here, and like make sure that this guys can be done like this. Yeah, we need to pass them. But how to pass them? This is like cool question. Let's put a bookmark here. Let's put a bookmark. Let's jump here. What else we can do here? We can delete this one. What will happen if we will try to pass? So currently we disable the check of our argument to be a function, because this check somehow doesn't work. I believe this check didn't work because we didn't recompile it. So let's uncomment this, guys. Put breakpoint here, recompile our sources, and try to run our C++ code and see if this check actually works. Because if we will not check our input variable, we will crash with unknown exception, and this will be like bad practice. So while it's compiling, let's check how to pass constants inside the JavaScript layer. Do we have some constant examples here? Do we have something like this? I believe we don't have examples, so let's check our solution again and try to find some examples of this. Yeah, this is how he defines example, how we use this example. So they have constants. And what is constants? Maybe, do I have constants here? Yeah, I have constants. So they export like this. They have not SQLite and not SQLite, have some constants. So we will check it with for sure. So before doing this, let's put our breakpoint here. We put our breakpoint, so go to test and let's run our C++ code and try to hit our breakpoint. Let's do this. and check that on conflict type is correct. Oh, no, it just takes some time. So yeah, now these checks are actually working. So what I'm interested in, what will happen if you pass not like lambda but different type? What will happen? Let's actually check it. So what if I pass here a number? What will happen? We'll run the JavaScript test and nothing. Really? Let's put a breakpoint. Just crash, but we crash with auto error. I'm not sure. Why my thing don't catch my exceptions? This is frustrating. Maybe I can go to configuration and stop on edit, stop on terminal, run in terminal, put true. Maybe this will help. I know, not C++, but where is our JavaScript? Where's yeah, this one. Run in terminal. Maybe this will give them some more information. Let's do it. So let's run this test. Nothing. Something wrong about our environment. So let's like manually check the exception. I'm really interested in what will happen. Let's like log it, format, and let's put breakpoint here and run it. Okay, we're capturing our exception, and this is like invalid archetype. On conflict, argument must be a function. So yeah, this is like readable exception. But what will happen? What will happen if we just remove this cast or remove this check? What will happen? Let's recompile it. Every minor detail needs to be recompiled. And maybe I can use different build system that will speed things up. Like we change only single file, but lots of files get recompiled because this single file get linked in get attached to a lot of different other files. I believe this is how it works. Maybe some advanced build system. Do you know, guys? Can Ninja, for example, build system work around this issue? So like, I don't recompile one file, I recompile lots of files. This is frustrating. So let's try again. What is it? What will be exceptions this time? There's no exception. It's just this. Straightforward death. How is possible? How is possible? Let's put exception here. How is possible? We're just dying. Wait. Okay. The cast was successful. So even though we passed just a number, the cast to function will be successful. And what about here? Okay. Okay, what will happen if you try to call this? It just crash. Okay, okay. So this guys is crucial thing to do. So if we don't like validate our input, and this invalid input will get inside our like lambda, it will crash the system without like any output. Just straightforward death. This is not what we want. We want like test like this. Okay. Nevertheless, so pretty much our feature is working right now. Like our test will pass without any issues. If we refactor it like this, I believe I just can run like this, and this also will be working. Yes. Yeah, I believe it works. Can we just run this file, for example, our debug node our file? Yeah, everything is green. So yeah, pretty much hooray, our feature was implemented. It took us like 7 hours because we like configured like environment, learning C++ and everything else. But now the last thing I want to do is I want to learn how to pass constants inside our system. So what constant I do want? I want this constant. Change data, change not found. I want like this one. I want my constants to have this variable. Yeah. How to do it? So we have example of these guys. So let's search how they do this. So let's show. No defined constant. So this is how they defined it. Yeah. Anything else? Constants dt. This is for TypeScript. Not very interesting. Blah blah blah. Text. Some switch cases. And some assertion. Yeah, this is how they test the constants exist. Yeah, we can jump and write the same test here, and it's like a cool test. We'll check like only these guys. Let's check this is equal to what? Hold on a second. Number 2. Back. This is like number 2. Yeah. And SQLite change set constants defined, and let's run only this test and remove these guys and this one and run this test. And if we run this test, we get undefined is not equal to, so we need to add this constant. So to add this constant, I think pretty straightforward. We need to find these guys and just here add our constant. And our constant is named like this. Yeah. But what is not defined constant? So this is some macro. What macro does? What this macro does? It constructs name of this constant the same as input, and define property on target with some attributes. What's attributes? Read only, don't delete, so you can delete it. Okay, so yeah, this is basically it. So we need to recompile. Let's read some V8 once more. So yeah, defining numbers, even defining numbers in V8 is not trivial task. Look at this. It's like takes 10-11 lines to define the number. This glue is ridiculously complex. Why we ever do this? Why we would like to use V8? Why we don't use like some assembler and compile it on fly? Because V8 code in Z compiles to assembler to optimize some stuff and then recompiles. Why we'll do it? Because it's like platform independent, yeah? So if we want platform independency, we want to write like this. I will think about it. So this guy should be done, and let's run our test. And test pass, hooray. So basically we did it as the issue. Like it took us 7 hours. How much time we 20 more minutes. Hold on a second. What else we can do? Because other stuff is trivial, yeah? Other stuff is pretty trivial. We define more constants, we mutate more tests to support new abstraction. What else we can do? Let's check his C++ code. Maybe we have missed something. So yeah, we're defining some stuff. But for example, this. Okay, let's check their solution and what they did. This was done by me. This was done by me. This was done by me. And here, how they cast as function. And how do I cast? I believe I cast differently. I just use cast. And I don't know what the difference between as and just cast is. But nevertheless, let's check it. As function, have our lambda. In our lambda, yeah, this guy, like, check this. We have cheated a bit. We created one variable and treated it as an array because we know that in C++ arrays of length 1 are equal to variables. But he constructed a real array, and yeah, it's basically more syntax for the same output, but nevertheless. He used new, integer new, we use number new. I don't know, like, is it like big difference, integer or number? He used try-catch block for something. He describes try-catch block. Interesting. And how do try-catch block works? So after calling JavaScript function, we can check if this function caught some exceptions. And if it caught some exceptions, we can just straight an exception and return abort. So we haven't did this, guys. So we haven't processed exceptions from the JavaScript, and this would be cool to process exceptions from JavaScript. Try catch, isolate. So let's create our try catch. Why not? Try catch, and it needs isolate. Isolate once again is our JavaScript virtual machine, and perhaps they need namespace, and we need semicolon. So yeah, and so after we have called doing just like put it like there here. And after we have executed our function, let's like try catch. What we can do? I think it's just has code. Yeah, he has like has code. Yeah. And here we can return our abort. Let's change that abort. And he also wants to rethrow. So we can. Why do we need to rethrow? I don't know, guys, because I think nothing will catch. No. We want to rethrow that this applies chain set will also throw. Okay. So try catch is pretty straightforward. It's nothing fancy. Invalid value. Const expr after. What is this, guys? Do you know this C++ syntax? What is const expr? Compile time constant evaluation tells the compiler that value must be compiled at the compile time if possible. Well. I don't know what is, but I believe if you have like a big computation like square root of, like this, if you have like this computation, the compiler will try to, during compile time, resolve the computation to a number and replace it by the number. But C++ has a keyword for this. This is once again why like people don't like C++. So if it's not is int42 result invalid value. So before casting we need also check stuff. So before we can do like this, before we have do result as, no, we don't use like this. Yeah, we do like this. Yeah. Before we do like this, we need to check that the answer is actually int42. Yeah. This will be useful because we get like our crash if we don't check. And invalid value is like -1 somehow. Why it's -1? I'm not sure why it's -1. What else have we forgot? We forgot like this and this. I'm not sure what is this. So we added escalate OK and escalate abort. Why have we added escalate OK? So we somehow rework this, guys. We check this, we remove this and edit this. Yeah. He made the logic more straightforward, I think, but it doesn't change anything. So what I'm really interested in, like, is there comments, like what in discussions. What we forgot, guys, we forgot to validate our casts and forgot try catch scope. Yeah, not a big of issues, but these are issues, and I'm looking for how we could find them. So if we could search code for some snippets, for some examples, we could see that people use try catch and validate inputs. Yeah, next time we will be more careful. Returning non-number from the callback essentially results in defined behavior. It's a value to is that inconsistent returns a valid number of raise error downstream. I'm not sure. See like this. What's this? Good catch. So they want to. So before this fix, there was some invalid behavior because we haven't returned correct number from our C layer. For our C layer, but they fixed it. Yeah. Because before this, we just make a cast and cast return some nonsense. We don't want nonsense. What is this, guys? He added a test to check this. Yeah, -1. What is -1? What is invalid value? It's -1. Okay. Wait, parameter is using. Yeah, he just checked this out. So this pretty much it with this feature. How much time? We have 10 minutes. Let's recollect our insights, what we did during this short session. So we learned how to configure C++ environment. We learned how to build it. We learned how to resolve dependencies in C++. So before, we see a lot of red lines here because we couldn't find V8 dependencies because C++ notoriously bad at resolving dependencies. But there is like bare program that you can compile and it will produce compile commands. Compile commands is just on database. It lists all the dependencies of our project, and our IDE can use clang-d to mount this file and search for dependency resolution like this. It's not straightforward, but we learned about it. The next thing, we learned how to put breakpoints inside C++ code. So to do this, we need to run LDB and connect it to these guys. But our breakpoints was not hit when we run tests. This is because during test, Node.js summons like additional copies of Node.js. So like, we're launching Node.js and the Node.js launches Node.js that launched Node.js. And this is why our LDB debugger couldn't like find a breakpoint because we haven't been attached to correct process. But after some time, we discovered, after talking with very smart guys in the Node.js channel, we discovered some flags how to disable it. And now Node.js doesn't spam additional processes and we can attach to breakpoints. It's quite interesting. So next we discovered how V8 works, at least at surface level, yeah? So we learned how there is like isolate. Isolate contains contexts. In contexts we have scopes, and we can create variables in scopes, and we can validate the variables, and we can cast the variables, and we can throw exceptions, we can do try catch. Pretty much it. So V8 IPA is not that hard, but it's like it's a bit of a pain in the ass to use, yeah. So if like this, if we check, where is it? Yeah. If we check like this, we can check this macros. So this is like V8 API. It's not very hard, but it's a pain in the ass to use. Yeah. But this is V8. Every browser has V8, not JS browser. Oh, hold on a second. Every Chrome browser has V8 inside, so it's like a pretty big project. But really interesting to do is like fuzzy test our function and check if it has like some vulnerabilities. But I don't know how to do fuzzy tests. But V8 inside like was written by very professional developers, and they have extended fuzzy testing in V8, I believe. So we can like check, where is it, dependencies, V8. They have a lot of fuzzy tests here. Bazel, what is Bazel? I do not know. Third party include tests. Yeah, they have fuzzer. So we have a lot of fuzzers here that we can like examine how they test the code with fuzzers. I believe fuzzy testing is the future of software development because it's not done like a lot today, but it's the most powerful way of testing stuff. What else have we learned? So we like spent so much time. What have we learned also? Some navigation basing, some V8, some we also in Node.js there is like unicorn velociraptor, input output UV library. So we need to check how they make promises, how they read files is also really interesting. What else we can learn? How much time we have? 6 minutes. There's a lot of time left. We need to learn something else from this project, guys. We have 6 minutes left. Maybe we can like see commits and see initial commit on the... He started with docs. By the way, tests was red. I believe Node.js have issue that some tests are flaky. I've seen that they discuss that they have a lot of flaky tests and that any test can fail in Node.js. And this is also interesting thing to discover. I think there is a deadlock inside V8 in some conditions, and people currently try to solve it. But somehow they didn't save the output of CI system. This is not very convenient, guys. What else? Let's check the first commit. The first commit was just like docstring, not very interesting. The second commit, what he did. What was the second commit? Again, just docstrings. Formatting. What is formatting? Just reformat some code. So much commits, they do nothing. Then once again some reformatting, and then some documentation, extensive documentation. They use extensive documentation. We check this invalid value, error handling, escalate documentation. So what we haven't did lots of documentations, and documentations are needed in a real life project. This is like a very important part. Like this. He added a lot of documentation, and even like something like in HTML. Holy moly. So if you want to add changes inside like big projects like Node.js, you need to excessively write documentation because people read them. It helps a lot. Some tests, I don't think I can learn something more from this. I was really interested in how Node.js makes the objects and resolve in objects keys. So how they do construct maps. So how they this I think is a hash table, some form of hash table, perhaps something else. So I was really interested in Node.js implementation of this table. Perhaps now we can just like dig around and find this hash table. How much time? 3 minutes. Maybe we can find hash table. Let's spend all our time on learning. So we have object of V8 is the core thing. Object. Do we have like implementation of this object? Set. Okay, I want to find implementation. Okay, set. Key. Okay, how V8 uses the key. He constructs utils open handle. What is open handle? Open handle in V8 is some form of macro. Some checks handle. What is handle? Handle is just local variable. for historical reasons. Okay, it's just local variable for historical reasons. Okay, we construct key value. What we do? Set object property. We need set object property. Key. Okay, we have key. Set object property once again. Maybe here key. No side effects to maybe string. Maybe property to handle. Key non-object property. Property lookup. Key. Lookup. Do I want to check lookup? How they search for the key? Maybe I want to check it. So they iterate over the lookup. How lookup works? This is some class. And it just has an iterator. Where is iterator? I'm not sure how C++ works. Lookup key, lookup. There's like lookup iterator, and lookup iterator take lookup key, and lookup start object, and lookup start object is just object. Where we're searching lookup key, it's basically the key. But why we need to construct key? Hold on a second. How we construct it? Just isolate key success. Isolate key success. Yes, this one. We use this constructor. And how this constructor works? We take our key and to integer index, to name. I will not have much time. I have 8 seconds left, unfortunately. I really want to see how V8 uses hash tables. It's a really interesting algorithm. Maybe I will do a different session to this. Because reasons. Maybe there is like something interesting for me. I really want to know how they do it. Just like convert to name. Unfortunately, we don't have much time. Yeah, next time, guys. So thank you for your time. Leave a like, subscribe to the channel for more content. And next time we would look at something else, because this issue is completed. We did it like in 7 hours. It's our record. Perhaps the next thing we will do is I will do some sort of programs that will search code snippets. So for example, I want to select my code and search these code examples that look something like this. It will use like artificial intelligence, some machine learning algorithms, construct indexes. We will check it later. So once again, thank you, and see you next time. Bye.